We're going to learn about design patterns in microservices. So what is meant by design pattern and what are the different types of design patterns that you have to follow in your project design where you develop a huge size of projects and it should be there for long time. Okay, so we are going to learn this design pattern. First of all, we should know about what is the need of this design pattern. So design pattern, with the help of it, one can be successful in their project while they apply the concept of design patterns. So what does mean by design pattern? So the team will work on various projects, and when they get a successful project, and so they will apply the same kind of a pattern, the principles or the protocols, the rules, or the technology to build a similar kind of an application when it comes to an organization. So that is why every process that is followed in the previous or an existing work application which was successful, that is called as a design pattern, will be applied. The same kind of solution will be applied in similar kind of application while we build. For example, while you develop a web application, and so you have started working on developing the application from the front end as well as the back end, and while you connect the process, how you started and what are the problems that you have faced and what are the code that you have written for overcoming those problems, or what are the solutions that you have find for a particular issue or particular error when it has occurred. So how you handle those kind of an error in the previous project, similar kind of a business application or a web application or a mobile application, when it comes for development, you may apply those kind of previous experience or previous solutions on a similar kind of application. So that is why we need to learn about pattern. So what is meant by software design pattern? So as the design definition goes, like software design patterns are defined as a software template or a description to solve the problem occurs in multiple instances while designing the software application or a software framework. For example, while you develop or pay attention to your customers, the customers one project, the customer are very much explicit in expressing their requirements, and a similar kind of a project when the customer is not opening up their requirements in that much detail, so you can pose such kind of questions, and because you had an already an experienced yeah, experience on similar kind of project or interaction with the customers, so same kind of questionnaires or a template you can have, and you can talk to your customer and know about their problem, and you can bring a solution with the help of different software frameworks. So design patterns will be reusable solution to a common problem in any software design. So it is a best practice, and which is suitable for object-oriented software development for the developers. So but it's a terminology and which is applied to any particular scenario. If it is a web-based application, so web-based patterns based solutions and the templates you can fall for, you can use it for solving those kind of issues when it arises. Maybe you have handled different types of exceptions, and so you can write a code here also similar kind of exception handling mechanisms. So that is called the patterns. And now we are going to learn about how this pattern will be useful while you design microservice based application. So what is meant by microservice? It is also one of the architectural style, and you can use this kind of an architectural style for developing a software application. As you know about it, there are different architectural styles, data center, data flow, layered architecture, object oriented architecture. So microservice also one of the architectural style which gives you idea in this topic. You will get lot of key points, and with the help of it you can build an application. But when it is useful while you build a large application, that time this kind of a microservice concepts you can apply, the architectural styles and pattern you can follow in your design. So microservices allow a large application to be separated into smaller independent parts, with each part having its own realm of responsibility. So far in your project, you may not follow such kind of microservice based design. And what you have followed is called as monolithic based design while you develop an application. Everything, okay, they may not have much more layers and may not have multiple request handling services. Everything will be have there is one entry point and one exit point. The services may not be attended by, there are different path through which the services may not be rectified. So that because of that, the more complexity, the more dependent path will be there. If one component is eliminated, then everything will be affected. So such kind of problems you may face in monolithic based application. If for a single update, single modification, you have to run the entire path of application that is designed, the data flow you have to check. But in microservice based application, there are different services, small modules which are developed to handle each service. Means, okay, the client requests, the server responds. Similarly, the module will respond back to the request of the client. So there are smaller independent path, and but each having its own responsibility. We are going to see more examples about it. So first we should know the principles of microservices. So what is the benefit of microservices? Means, okay, it's enable fast flow. So you can request and the response will be faster. Any customer, when they interact with your application, they can get the solution very fast. For example, there is a Paytm application, and so such kind of APIs when you have, the request and response will be faster. There are different APIs, different which are handling a small part of a service, that payment services. Instead, if you have a net banking, so compared to that, this flow is faster, right? So, what is the benefit of microservices, or the principles that you are applying in microservices? So, microservice architecture which enable fast and sustainable flow of changes in the team topologies, or otherwise in the development operating systems, DevOps also. These two enables you enable the developers of to develop and make the satisfy the request of the client, handle it in a faster way. So that is the aim why people are shifting from monolithic to microservice architecture, because of this reason only. So for a business to thrive in today's volatile, uncertain, ambiguous world, so IT must deliver the software rapidly, frequently, and reliably. They're based on the customer needs. For a business application, on a particular scenario, on today's world situation, or based on the current situation, you may have identified one or a particular direction of flow of data is supposed to be take place through your software. But later on, you are finding out due to some unpredictable market situation, something can be predicted and something cannot be predicted. So, due to some unpredictable situations, you started identifying certain things and you want to bring it back inside the software. So, such kind of times, when you follow monolithic application, it delay the software in terms of release, and the development will be slower. But when you follow this microservice based architecture, it just speed up your development, as well as you can get the version release frequently, and the application will be 100% reliable. So to do that, for large complex application, we need this success triangle, right? So it should enable a particular topology should work, and the software operating systems and everything are going to support. And with the help of it, what are the benefits of microservices? Here you can see. You will get a resilient services, independent autonomous services, real-time load balancing, scalability, availability, decentralization, continuous development, continuous delivery of your application with the help of DevOps integration and auto provisioning, isolation from failure, seamless API integration, and continuous monitoring. All these are so you can scale up, you can improve your business, extend your business, and extend the services to some other branches also. For example, if you are offering a freelance services, so some more customers are going to join, or some other features will you add, but you need to maintain a decentralized architecture in your business. So that is also possible. But at the same time, load balancing, because load balancing is very important concept in microservices for handling the request of users through synchronous asynchronous way of handling the information. So multiple users, when they request or interact with the same object or same kind of product ordering, okay, how you can handle it. There is a very well representative algorithms will be included for handling this load balancing task. So the both user will get satisfaction. And at the same time, ordering part, okay, so this is about raising the order from the suppliers, okay, to the supplier. So that is also parallelly going to take place, and there will not be much delay. So immediate response, immediate, because every customer, when they visit your online shop, they should get benefited, they should not be disappointed. So if you lose a single customer, there is a huge business loss, because the same customer will come to your business again and again for a long period in their lifetime. And you should not lose any single customer. There is one single object. For example, there is a shirt, and which is chosen by two or more customers at the same time. So you have to satisfy them by okay, so whoever come first, first come first service basis, you have to respond to them. But maybe there is a possibility of giving them with additional recommendation. This is out of stock, but in case you can reorder it, or you will get it in some certain time period, or you have to recommend them in case that kind of an option, if your business not is not having, then you have to give them some other choices through a recommendation algorithm. So such kind of things you have to include, and you can perform with the help of microservice architecture only. Okay, so all these are some of the benefits. And okay, for example, a customer who is ready to always trusting that net banking is the payment method which is more secure compared to other payment option. So such kind of option also you must have in your application. So that API also you should integrate. And some users always trust Paytm is the best one, and they do transaction with that, or GPay. So you should allow them to, so that means your software is supposed to be integrated with such kind of APIs. Then only this kind of a user will, our customers will be get satisfaction, and they can perform well. And continuous monitoring part also. Sometimes the customer is searching for some other option, that also you should predict what else they need. So that analysis also behind the application, you have to do it with the help of microservice based architecture. Monolithic architectural style, this kind of tracking, following more precisely will not be there. So that is why at present most of the business applications and organizations are moving towards into the development of microservice based architectural styles. So, what are the design patterns that you have or you can follow in your microservice design? While you design the software as a developer perspective, what are the design patterns that you have to incorporate? There are different design patterns are there. You can choose based on your requirement. So the first one is first style is called aggregator. So what is meant by aggregator? So it collects related item of data and display them based on DRY principle. So aggregation means it's a combination of summing up something. Okay, so one request, another request, multiple requests will be there. but everything you have to combine together. And the one, for example, what is memory aggregator while you apply in a shopping, manual shopping also. For example, the customer may pick from one floor to another floor, but he want to do billing in any floor. That option must be there. So the data must be integrated every time. An aggregation must be applied. An aggregation operator will be applied. So when they want to close it at the time, so such kind of services must be there in your business. Similarly, online shopping. Okay, so they can order one, and from page N they can choose another product page N. Okay, so in the beginning of Swiggy application, they don't have such kind of service. If they want to order, okay, one hotel, multiple items they can select and they can finish it. And they cannot, the same customer cannot order from, one single order itself. They cannot place the order with multiple restaurants. So such kind of things you have to take in care in your business, because of the customer feel that okay, it takes much time. So that, what is DRY principle? DRY stands for don't repeat yourself. So what is DRY? For example, in Java, we have learned so many principles like KIWS, keep it simple principle, open close principle. The class is supposed to be open for modification, and or do you want to close the classes which are not supposed to be modified. So such kind of rules we used to apply. So similarly, but at the same time, what is meant by this DRY principle is reduce repetitive patterns and duplicate code and logic in favor of modular and referenceable code. So repeating the code, which the same code, the same module should handle okay multiple requests. So as I have told, they have to completely order in one restaurant, they have to close, they have to come back, and they have to reorder again in some other shop. So you should, through your application itself, multiple items, multiple requests. So everything you have to combine, and as a finally the result you have to produce, and that is supposed to be the response for the request of the client. So a service, what does mean by aggregator? A service that receives a request, then makes the request of multiple services, combines the result and respond to the initiating request. So this is how aggregator based concept, this kind of a design pattern you can incorporate while you design certain applications. API gateway may be public, or it may be, for example, when you consider API gateway like Google Map services, which is public, and anybody, if you want to integrate with your application to know about your restaurant, then such kind of an application can be. So automatically your roadmap will be given, and the location and the details will be integrated over this, or entered or embedded over this application. So which is a protocol which can able to handle the request of customer from one end to the another. So it is an API, this API gateway which acts as an entry point to forward the client's request to appropriate microservices. If you choose the API gateway of Paytm, then as per Paytm policy, your payment options, taxes will be included while handling such kind of requests. If you have chosen the API gateway through the payment of GPay, then through that your service will be handled. So API gateway is also brings a solution to the customer's need. That also you can incorporate inside, but you have to write a code to connect this or to link with this API gateway alone, and you no need to develop this payment path, and that simplifies the task of customer as well as from the developer to get the solution. So client can access through mobile application as well as through desktop application, that is a web application, or through mobile application. So yeah, but both are support, through that they are going to do one particular service. They want to access a particular service. So this API gateway will redirect the request and handle it and respond it back. So gateway aggregation pattern is also going to work here. Is a design pattern, and which is used in the cloud computing platform, and where there is a unified entry point for client to access multiple. There is one single entry, but multiple requests can be accessed. The same payment gateway of Paytm, you can do shopping, or you can access the petrol bunk for doing payment for your uh, services, or you can visit different type of shops, and through that you can get different kind of services. But there is one single API gateway through which the payment transactions you can do, but that will be reflected back in their application. Okay, so in this pattern, there is a single gateway service which is responsible for receiving, handling multiple client requests, and the gateway routes each request to the appropriate backend service, aggregate the responses, and return a final single response to the client. So such kind of design patterns you can include in your application. The next design pattern is called chained or chain of responsibility. So, for example, your request is coming to a single entry point, but it is supposed to be handled by multiple services, and at last you will receive a single output. So, this kind of a service are designed pattern which produces a single output, but which is the combination of multiple chained outputs. For example, there is a progress report we used to generate for each student, but we have a module called attendance, and that when we request that respond back with the response of printing the details of the students attendance, and service B maybe one single subject, and what is their pass mark, and the student scored how much, and the details about the faculty. And service C another subject. Okay, service D maybe the fees, whether is there any due on this particular month or not. So all these results, a progress report is a final output. It's a single output, but it is a combination of multiple chained output. So such kind of design patterns, but you have to break down and make them as a small services which should respond. For example, in a college, there are different divisions, each division having its own structure. So each structure through which you will get different services. When you visit office, you will get different kind of service. When you meet your mentor, you will get different kind of service. And when you meet your HOD through him or through her, you will get different kind of services. But at last, the service is enable the student to complete all the problems that are supposed to be solved in a particular semester, or get a solution on a particular semester. So that is why there is a breakdown architecture. So this kind of an microservice based architecture will be more useful if everything run under one single. For example, for the whole university there is one office, one HOD, one principal. So it's very difficult to address all the needs of the customer. So that is why the request and the response. So what does mean by service A? Service, for example, customer A may request a service, and service B may execute, and the student may get a response back. So such kind of synchronous and asynchronous services may be there for, and that you have to handle through the design pattern. For example, in an online shopping page, while you return a particular product, behind that there are different service sections which are able to handle and respond you back with what you want, whether you want it in terms of money, refund, or you want to go for again purchase. But at the same time, okay, there is a chain of different units will handle your request, not by a single entry point. So maybe single entry, but the services will be handled by multiple service, that is called chained or chain of responsibility. So such kind of design patterns you can include in your architecture. So here also it is given. So in an online shopping part through web pages, you're giving a request, and you may think it is an order, but there are other sections which are immediately they'll receive their notification, and they supposed to started working on. The courier person should come and collect, and he's supposed to respond back. So likewise, the email and SMS, all other messages supposed to confirm with the different type of users who are involved in this particular operation. So there are chain of responsibility which is supposed to be linked and to handle the user's request. So such kind of microservices you can include in your design pattern. So here the handler will handle the particular request, and in case if it is not able to handle, the request will be given to another handler. So here also withdrawal of money. If 500 notes are there, okay, as per the request of the customer, that will be dispatched. In case if it is not there, okay, so it will go to the next handler for okay, choosing the different combination of amount, and then it will be dispatched at last to satisfy the customer. And every time this account will be updated, even the money is entered by the user, at the time itself it will verify whether there is a sufficient amount. In case if it is not there, the handler will reinform. So that is why if the request is not fulfilled by any handler, at least you will get the answer no. So as per this, this is also a kind of a pattern through which the request of the customer or the user's request will be handled in the microservice architecture. The next architecture based design pattern of microservices, asynchronous messaging. So what does mean by asynchronous? So all the services can communicate with each other, but they do not have to communicate with each other sequentially. For example, you can straight away go to page number N in case if you know product ID or any particular shop, if you want to browse and you want to do so, that also supposed to be there. No need to go through step by step. Straight away you can go for that particular module and you can start, or you can do a request. So that kind of messaging servicing system also supposed to be there in your design pattern. For example, for that purpose, there are different type of request response handlers. So whether it is asynchronous one-to-one, simultaneously they can go without any direction. For example, you should read, understand, then only you can order. There are such kind of things will be there. But straight away you can go and order straight away in a game application also. But there are some game application very stringent. You should know, read step by step, and then you have to proceed. But yeah, more okay, straight away you can go. And simultaneously, for example here, okay, when the customer raises this, it will go to this level. As I have told, for example, when the customer is requesting for a particular order, the message broker module or the service will place the request of each and every customer here, and one by one customer queue will be answered back. But simultaneously, more than one customers can place their request. But some of the application, only one the request, when it is satisfied, next customer can come. Okay, so next will be, this is kind of a queue. But the queue can be okay, so you can apply different algorithm based concept to handle the request of the customer. So that is called asynchronous one-to-one, or asynchronous one-to-many, or asynchronous sorry, one-to-one or one-to-many basis. The customer's request will be handled by the web application or through a mobile application when the request is placed. The next type of microservice design pattern is designing the database. So database is also very, very important. So the data, every service, there will be a database which will be updated, or for okay, so such kind of architecture you can follow, or otherwise you can go for a shared database. So the same data will be database will be shared by several microservices. There are examples here. For example, a single database itself are can able to address the user while they log in or while they perform transactions, spending reports, notification and credit score, or user profile, or everything will be updated in one single database. But inside the database, there are collections of tables will be there. So each table can able to handle this kind of a request when it comes through this API gateway. So such kind of database pattern also you have to. So in database design pattern, if it is a monolithic application, so if it is the customer request comes through a mobile application or through a web application, the single database will be there, which can able to okay, the same database itself, the customer's request will be handled and reply back. But in microservice, for each service, for example, order a separate database, for refund or payment, separate database will be there. So that is called different data stores will be there, and which can able to handle a different type of services by the user. So that is called a cloud. In a cloud platform, you can put it, and different user requests will be handled by different resources. So this is the monolithic based database, and this is a microservice based database. So each microservice owns its data, but here it's a single shared database. So that is a difference. So in a cloud platform, mobile application, this is a microservice based one. For product, if you want to view the product backlog, you are accessing different database. If you're ordering, that will be from a different database. If you're shopping, okay, so different database, but at the same time, all these are synchronized. The same data updation, there will not be any duplicates here. So such kind of code you have to write and you have to manage. The next type of design pattern that you can incorporate in your software is event sourcing. So it creates events regarding the changes in the application state that will be recorded. For example, okay, so based on okay, when an object is clicked, a particular event will be generated, and this event will execute, and then it will present back to the customer. For example, but while you select an event table will be created. For example, filter, multiple filters will be there, 3 or 4 filters will be there. From first filter, when you started creating, okay, that will be stored. Second filter, that will be stored. Third filter, then it will be executed through the broker module, and then it will publish back to the customer. Okay, so that is called event sourcing. So event table will be generated based on the event. Okay, so it's an aggregated event, and then it will be published back to the user. So event sourcing is a different way of structuring the business logic and persisting aggregates. So it's a sequence of event, and what event means, it's a change of state of a particular final aggregate. Sometimes in between we want to do modification, means the same event table will be updated with some other modification, then it started publishing, but we doesn't know. Okay, every small okay, every small millisecond, this says, okay, the page is frequently updated based on the filters that you have chosen. Instead of clicking the button submit, automatically based on, okay, so generated event it will be. So event sourcing, event aggregates are stored as a sequence of events in this table database, which is called, this is called event store. So event aggregates generated by the user will be stored as an event store. So such kind of patterns also you can follow. The next pattern is called branching. So simultaneously process the requests and responses from 2 or more independent services. There is no dependency. So, but in case if it is needed, it combines or fetches result from different microservices. So that is called branching. For example, here there is an okay. So how every team is responsible for one or more subdomain. Subdomain is implementable model. It's a slice of business functionality, logic, rules, adapters, and communicate with them. For example, like same application, the consumer team, that is customer may log in, and the team member may log in and the delivery man will log in. But simultaneously, they should get different answers from the same database when they start, or when their query is given to the same database, but the response will be different. So that is called branching. So, how it is supposed to be designed with the help of some DevOps softwares, you can handle it, and finally you can deploy such kind of application back to the users. So you have to design in a Java-based application means, okay, you will have packages, classes, and finally everything will be into a single jar file, but execution will be different. Sorry, responses will be different, but execution happens maybe on the same application database. On the same application database, but different views are going to be given to different. And at the end of view, some views are permanent, some views are temporary. Virtual views also you can give. Next, command query responsibility segregator. So in short form, this is called CQRS. Command query responsibility segregator based design pattern. So application is divided into two parts. Here, command and query. Command handle all the requests related to commands like create, update, and CUD, create, update, and delete. Query, okay, just give back only the view. So that is called command query responsibility segregator. This kind of a pattern you have to apply in your design. Here there is an example. CRUD, crude. What is that? Create, read, update, delete. All these are called as commands. Right? Yeah, commands and view. Query means, for example, there is a customer or user, consider like it's a user, and he's giving certain things. I want to see size, color of this particular product. Through some filters they are selecting. So this will be handled by the query handler. And okay, so this will be given combined together as an event store and that as a projection, and you just read from the database and get the details and respond back to the query results, respond back to the um, viewer, right? And but he's the same person want to create an order, so at the time that will be created by the command handler. So there are query handler and command handler will be there as a separate microservices. So here, command handler maybe update, modify, or sum up all these will be stored in the event store, and they will respond back. In case based on this query, certain things are happening, that will also reflected back in the customer's end immediately. For example, on a single day, if I started purchasing through an online shopping, but from the admin side, my request is I'm searching, I'm going to I'm viewing the product prices. Suddenly, the admin side, they are offering or including certain percentage of discounts, and that will be that is supposed to be reflected back in that particular milliseconds when they submit. So that kind of microservice system you must have as a query handler and a separate command handler. Then only this kind of possible interactions based pattern architectural style you can include for solving such kind of problems of the users. So queries return the result without changing the observable state, whereas commands will change and return a value. So this is called this is also a design pattern that you can incorporate in your application. So command will be handled by its separate event stores and event bus. Query will be handled, but at the same time, everything is supposed to be synchronized. Next pattern is called circuit breaker. So it is used to stop the process of request and response if a service is not working, because you have put it as a separate service. If service A is not, you want to cut off, or you want to find out whether service A is working or not. So you must have a separate files, and you have to run, and you should analyze why this failed. For example, yeah, when you just click a discount, that should be reflected over all the products. But certain products are not responding, then you have to run and you have to find out because of which service, or it is under what type of service this is not supported. So if it is success, okay, it is highlighted in here green color, okay, this services, but why it is not there? Okay, so or do you want to, okay, why it is not connected, which is this cut off from this application? So that you have to find out, and you must have such kind of log also, and you have to monitor and support or track your users. Okay, so why it is timeout, from which time onwards this is not done, and likewise you have to do an analysis. If you have such kind of services, then only you can do an analysis. The next one is called decomposition. So what is meant by decomposition? So decomposition of applications based on the domain and based on the business, based on the pattern, you have to split the application. For example, if it is an e-commerce based application, you can classify as main, an order transaction, and an intelligence services, like inside that. So this is how you have to create a breakdown architecture for your application and connect with wherever there is an API is needed, third party API, public API, or private API applications if you have. Okay, so that you have to connect and you have to complete the architecture, and also give an animated view, and divide the application. Okay, the logic, whether all the logic is working fine, the implementation is working, and the deployment is done for perfectly, every application is installed, supported in the client or in the user system, and the process also you have to check. So this is how you have to check the overall system, whether it is active, or you should know its status. Somewhere in some microservice architecture also, you can have some monolithic based pattern for certain modules. So here different combinations is given. So for example, product orders invoicing may be some monolithic outside the calls, and but somewhere this can be monolithic, and this is this alone you can convert that into microservice, or everything can be microservice, or this alone monolithic and this alone. So it depends upon the application. You can just use the